Yes, next one, the next experiment results that are based on photoelectric effect of frequency of incident radiation. In that, the variation of photoelectric current with the collector plate potential with the different frequencies results in the observation that is the first one. The value of a stopping potential is different for different radiation of different frequencies. The value of a stopping potential, what we are written over here, ನೋಡಿ ನಾನು ಇಲ್ಲಿ ಏನು ಬರೆದಿದ್ದೇನೆ, that expresses the stopping potential or retarding potential, that is expressed by minus of V01, minus of V02, minus of V03 for the frequencies of mu1 as well as mu2 as well as mu3. Mu3 is greater than mu2 is greater than mu1. Therefore, the value of stopping potential is different for different radiation of different frequencies. That is the first observation. As well as the second one, for the higher frequency of radiation, that is for mu3. For the higher frequency of radiation, the value of stopping potential is more negative. For the higher frequency of radiation, that is mu3, for that the value of stopping potential is more negative compared to V minus of V01, minus of V02, minus of V03. Minus of V03 is more negative. Compare these two. That is the reason why for the higher frequencies the stopping potential is more negative. That is the second conclusion. As well as the last one, the value of saturation current is independent. That saturation current that are over here, all the frequencies that will meet at this point is considered as a saturation current. The reason is that as the collector plate potential increases at a increasing intensity, as the intensity increases, the collector plate potential, as the intensity increases, the emission of electron increases. That electrons are called photoelectrons. That emission is called as a photoemission. Thus the photoelectric current increases, then the current saturates. That point is considered as a saturation point, or this point is considered as a saturation point. Therefore, the very important one, the intensity is independent of their frequencies. Therefore, I repeat, frequency of incident radiation, if you plot the graph photoelectric current versus the collector plate potential with the different frequency of incident radiation, that results in, ಹಾಗಾದರೆ ಇದರ ಅಬ್ಸರ್ವೇಷನ್ಸ್ನ ರಿಸಲ್ಟ್ ಏನಿದೆ ಕೇಳಿದರೆ ನಾವು ಫಸ್ಟ್ ರಿಸಲ್ಟನ್ನು ಬರೆದಿದ್ದೇವೆ. ದ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಸ್ ಡಿಫರೆಂಟ್ ಫಾರ್ ಡಿಫರೆಂಟ್ ರೇಡಿಯೇಷನ್ ಆಫ್ ಡಿಫರೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸೀಸ್. ಪೊಟೆನ್ಷಿಯಲ್ ಅನ್ನುವಂಥದ್ದು ಅಥವಾ ಮಿನಿಮಮ್ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅನ್ನುವಂಥದ್ದು ಬೇರೆ ರೀತಿಯಂಥ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಅಥವಾ ವೇರಿ ಆದಂಥ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ವೇರಿ ಆಗಿರ್ತದೆ. ನಾವು mu1 ಮೈನಸ್ ಆಫ್ V01ಗೆ ಬರೆದ್ರೆ, mu2 ಮೈನಸ್ ಆಫ್ V0ಗೆ ಬರೆದಿದ್ದೇವೆ, mu3 ಮೈನಸ್ ಆಫ್ V03ಗೆ ಬರೆದಿದ್ದೇವೆ. ಆಸ್ ವೆಲ್ ಆಸ್ ದ ಸೆಕೆಂಡ್ ಅಬ್ಸರ್ವೇಷನ್ ಬೇಸ್ಡ್ ಆನ್ ದ್ಯಾಟ್, ಫಾರ್ ದ ಹೈಯರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ, ದಟ್ ಇಸ್ ಫಾರ್ mu3, ಫಾರ್ ದ ಹೈಯರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ರೇಡಿಯೇಷನ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಈಸ್ ಮೋರ್ ನೆಗೆಟಿವ್. As well as the last one, the value of saturation current, this point is considered as a saturation point. Already explained ಮಾಡಿದ್ದೇನೆ, ಸೆಕೆಂಡ್ ಕಾನ್ಸೆಪ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡುವಾಗ. The value of saturation current is independent of frequency of radiation. ನೋಡಿ ಇಲ್ಲಿರುವಂಥ ಲೈನ್ಸ್ ಅನ್ನುವಂಥದ್ದು ಏನಾಗಿದೆ ಕೇಳಿದರೆ, ಆಲ್ ದೀಸ್ 3 ಫ್ರೀಕ್ವೆನ್ಸೀಸ್, ಇಲ್ಲಿ 3 ಲೈನ್ಸ್ನಲ್ಲಿ ನಾನು ಏನು ಫ್ರೀಕ್ವೆನ್ಸಿಯನ್ನು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿದ್ದೇನೆ, ಆ ಎಲ್ಲ ಫ್ರೀಕ್ವೆನ್ಸಿಗಳು ಮೀಟ್ ಆಗಿರುವಂಥ ಪಾಯಿಂಟ್ ಹೇಳಿ ಕೇಳಿದರೆ ಇಲ್ಲಿ ದಿಸ್ ಪಾಯಿಂಟ್ ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಅನ್ ಸ್ಯಾಚುರೇಷನ್ ಪಾಯಿಂಟ್ ಸಿನ್ಸ್ ಇಟ್ ಬಿಲಾಂಗ್ಸ್ ಟು ದ ಕಲೆಕ್ಟರ್ ಪ್ಲೇಟ್ ಪೊಟೆನ್ಷಿಯಲ್. ಈ ಪಾಯಿಂಟನ್ನು ನಾನು ಎಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ ಕೇಳಿದರೆ ಕಲೆಕ್ಟರ್ ಪ್ಲೇಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದೆ. ದ್ಯಾಟ್ ಇಸ್ ದ ಸೆಕೆಂಡ್ ಅಂಡ್ ಕನ್ಕ್ಲೂಷನ್. ಇಟ್ ಮೀನ್ಸ್ ದ್ಯಾಟ್ as the frequency increases, second observation ಪ್ರಕಾರ ಏನು ಹೇಳಿದ್ದಾನೆ ಕೇಳಿದರೆ, as the intensity increases, the emission of electron increases. That is the reason why the photoelectric current increases. As the frequency increases, ಈಗ ಫ್ರೀಕ್ವೆನ್ಸಿಯನ್ನು ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಇದ್ದಾನೆ, the speed of the emitted electron increases. Very important. As the intensity increases, emission of electron increases. ಯಾವಾಗ ನೀವು ಇಂಟೆನ್ಸಿಟಿಯನ್ನು ಜಾಸ್ತಿ ಮಾಡ್ತೀರಿ, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕಂಡೀಷನ್ ಫಾರ್ ಎ ಫಿಕ್ಸ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಸ್ ವೆಲ್ ಆಸ್ ದ ಎಕ್ಸಲರೇಟಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್. ಆಸ್ ದ ಇಂಟೆನ್ಸಿಟಿ ಇನ್ಕ್ರೀಸಸ್, ದ ಎಮಿಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ಕ್ರೀಸಸ್, thus the photoelectric current increases. In the second case, as the frequency increases, the speed of these electrons increases. That results in the kinetic energy of the photoelectron increases. Is it clear? As well as the based on that, again we are followed by the one more graph. that is known as stopping potential as well as frequency of incident radiation for the two metals. Let A and B are the two metals. That is considered by the frequencies known as mu naught as well as the mu naught dash. ಇಲ್ಲಿ ಪುನಃ ಇನ್ನೊಂದು ಗ್ರಾಫನ್ನು ಬರೆದಿದ್ದೇನೆ. ಗ್ರಾಫ್ ಏನನ್ನು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತದೆ ಕೇಳಿದರೆ, ಗ್ರಾಫ್ ಏನನ್ನು ಮೀನಿಂಗನ್ನು ಕೊಡ್ತದೆ ಕೇಳಿದರೆ, ಗ್ರಾಫ್ ಅನ್ನುವಂಥದ್ದು ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಮತ್ತು ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ರೇಡಿಯೇಷನ್ ನಡುವೆ ಇರುವಂಥ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಅನ್ನು ಕೊಡ್ತದೆ. Therefore, the stopping potential with respect to the frequency of incident radiation for the two different metals, for that the experimental conclusion for a given photosensitive material, these two materials are considered as photosensitive materials, or these two metals are considered as photosensitive materials. ಯಾಕೆ ನಾವು photosensitive ಅಂತ ಹೇಳ್ತೇವೆ ಕೇಳಿದರೆ, which is make use of. ಈ ಫೋಟೋಸೆನ್ಸಿಟಿವ್ ಮೆಟೀರಿಯಲ್ಸ್ಗಳು ಏನಾಗ್ತದೆ ಕೇಳಿದರೆ ಇನ್ಸಿಡೆಂಟ್ ರೇಡಿಯೇಷನ್ಸ್ಗೆ ರೆಸ್ಪಾಂಡ್ ಮಾಡ್ತದೆ. ದಟ್ ಇಸ್ ದ ರೀಸನ್ ವೈ ದಟ್ ಮೆಟೀರಿಯಲ್ಸ್ ಆರ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಎನ್ ಫೋಟೋಸೆನ್ಸಿಟಿವ್ ಮೆಟೀರಿಯಲ್, ಆರ್ ದಟ್ ಮೆಟಲ್ ಇಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಎನ್ ಫೋಟೋಸೆನ್ಸಿಟಿವ್ ಮೆಟೀರಿಯಲ್ಸ್. Therefore, let A and B are the two different materials with the frequencies known as mu naught as well as the mu naught dash. Based on that, the first conclusion for a given photosensitive material, that is A and B, the stopping potential increases linearly with the frequency of incident radiation. ಗ್ರಾಫ್ ನಿಮಗೆ ಕನ್ಕ್ಲೂಷನ್ ಅನ್ನು ಕೊಡ್ತಾ ಇದೆ ಒಂದು ಸ್ಟ್ರೈಟ್ ಲೈನ್ನ ಮೂಲಕ. As the frequency of incident radiation increases, the stopping potential is also increases. There is a directly proportional relation between stopping potential as well as the frequency of radiation. As well as the second conclusion, for a given photosensitive material, ಇದೇ ಪಾಯಿಂಟನ್ನು ಪುನಃ ಇಲ್ಲಿ ಬರೀಬೇಕಿತ್ತು, ಜಸ್ಟ್ ಡಾಟೆಡ್ ಲೈನಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿದ್ದೇನೆ. ನೀವು ನೋಟ್ಸನ್ನು ಪ್ರಿಪೇರ್ ಮಾಡುವಾಗ ಈ ಪಾಯಿಂಟನ್ನು ಕಂಟಿನ್ಯೂ ಆಗಿ ತಗೊಳ್ಬೇಕು. ಫಾರ್ ಎ ಗಿವನ್ ಫೋಟೋಸೆನ್ಸಿಟಿವ್ ಮೆಟೀರಿಯಲ್ there is a cutoff frequency for which the stopping potential is equal to 0. What is the meaning of that cutoff frequency? ಹಾಗಾದರೆ ಈ ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿಯ ಮೀನಿಂಗ್ ಏನಿರ್ಬೋದು? As the intensity increases, the photoelectric current increases. As the frequency increases, the speed of the electron increases. Speed of the emitted electron increases. Thus, the kinetic energy of the emitted electron increases. But now, ಇಲ್ಲಿ ಒಂದು ವರ್ಡ್ ಯೂಸ್ ಮಾಡಿದೆ, ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ನಾವು ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ರೇಡಿಯೇಷನನ್ನು, ಇನ್ಸಿಡೆಂಟ್ ರೇಡಿಯೇಷನನ್ನು ಕಳಿಸೋ ಕೂಡಲೇ ಅಲ್ಲಿ ದರ್ ಇಸ್ ಎಮಿಷನ್ ಆಗ್ತದಂತಲ್ಲ. ಯಾವಾಗ ನೀವು ಇನ್ಸಿಡೆಂಟ್ ರೇಡಿಯೇಷನನ್ನು ಕೊಡ್ತೀರಿ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರುವಂಥ ಇನ್ಸಿಡೆಂಟ್ ರೇಡಿಯೇಷನನ್ನು ಮೆಟಲ್ನ ಪ್ಲೇಟ್ನ ಮೇಲೆ ಸೆಂಡ್ ಮಾಡ್ತೀರಿ, ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಅಲ್ಲಿರುವಂಥ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಎಮಿಟ್ ಆಗೋದಿಲ್ಲ. ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಮಿನಿಮಮ್ ಅಮೌಂಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ದಟ್ ಮಿನಿಮಮ್ ಅಮೌಂಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ದಟ್ ಈಸ್ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಫಾರ್ ಎಮಿಷನ್ ಆಫ್ ಇಲೆಕ್ಟ್ರಾನ್. ದಟ್ ಎಮಿಷನ್ ಆಫ್ that condition is considered as a cutoff frequency. That is also expressed by the term is called as a threshold frequency. The threshold frequency below which there is no emission of electron takes place. ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಥವಾ ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ ಏನು ಬರೆದಿದ್ದೇವೆ, ಅದರ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅನ್ನುವಂಥದ್ದರ ಕೆಳಗಡೆ ಇದ್ದರೆ, ಅದಕ್ಕಿಂತ ಮಿನಿಮಮ್ ಆಗಿದ್ದರೆ, ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿಗಿಂತ ಮಿನಿಮಮ್ ಆಗಿದ್ದರೆ, ದರ್ ಇಸ್ ನೋ ಎಮಿಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. Therefore, the emission of electron takes place from the metal only if the condition is that the frequency is above the threshold frequency. Frequency ಅನ್ನುವಂಥದ್ದು ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿಯ ಅಬವ್ ಆಗಿದ್ದರೆ ಮಾತ್ರ there is a emission of electron takes place, the speed of the electron is increases. That is the reason why the kinetic energy increases. These are the experimental results that are based on the photoelectric effect. Yes, the next heading, very important 5-mark question, experimental observations of photoelectric effect. What we have studied by the graph, that is explained in terms of a sentence. In that, the first one, photoelectric effect is an instantaneous process. It means that as soon as a radiation falls on the emitter plate, the emission of a photoelectron takes place. The very important condition for a particular frequency, as the intensity increases, the emission of photoelectron increases, the photoelectric current increases. As the frequency increases at a constant intensity, the speed of the electron increases, therefore the kinetic energy of the electron is also increases. As soon as, in that the first condition, photoelectric effect is an instantaneous process. As soon as radiation falls on the emitter plate, there is an emission of electron takes place. If the radiation that falls on the emitter plate stops, the emission of photoelectric current is also stopped. That is the first observation. The second one, for every photosensitive surface, there exists a minimum frequency of radiation called threshold frequency, below which there is no emission of electron takes place. Second condition, I repeat, for every photosensitive surface there exists a minimum frequency. Already we have drawn in terms of the graph. Already na idra ಬಗ್ಗೆ conclusion ಕೊಟ್ಟಿದ್ದೇನೆ. If you plot the graph stopping potential, ಲಾಸ್ಟ್ ಕನ್ಕ್ಲೂಷನ್ ಏನಿದೆ, ಇಫ್ ಯು ಪ್ಲಾಟ್ ದ ಗ್ರಾಫ್ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ವರ್ಸಸ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ರೇಡಿಯೇಷನ್ ಫಾರ್ ದ ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇನ್ ವಿಚ್ ದ photoelectric current is 0, but as the frequency of incident radiation increases, the potential is increases. Frequency of incident radiation increases, the stopping potential is also increases. Therefore, for every photosensitive surface, there exists a minimum frequency of radiation called threshold frequency mu naught, below which there is no emission of electron takes place. The next one, above the threshold frequency mu naught, photoelectric current is directly proportional to the intensity of radiation, as I discussed in the first graph. The effect of intensity of radiation on photoelectric effect. As the intensity of incident radiation increases, emission of photoelectron increases, thus the photoelectric current is also increases. That is the third observation. The fourth one, for a given photosensitive material, the threshold frequency mu naught for which the stopping potential is 0. Already explained ಮಾಡಿದ್ದೇನೆ. As well as the fifth one, above the threshold frequency, kinetic energy of the emitted electron increases. Above the threshold frequency, kinetic energy of the emitted electron increases with the increase in or the frequency of incident radiation. But very important, it is independent of intensity of radiation. Very important 5 observations for a 5-mark question for the board exam. Write the experimental results or observations of photoelectric effect. I repeat, the first one, photoelectric effect and instantaneous process. The second one, for every photosensitive surface, there exists a minimum frequency of radiation called threshold frequency, below which there is no emission of electron takes place. As well as the third one, above the threshold frequency mu naught, photoelectric current is directly proportional to intensity of radiation. As well as the fourth one, for a given photosensitive threshold frequency mu naught for which the stopping potential is 0. Fifth one, above the threshold frequency, kinetic energy of the emitted electron increases with the frequency of incident radiation, but very important, it is independent of intensity of radiation. As the next concept, photoelectric effect and wave theory of light. Photoelectric effect successfully explains the particle nature of light. If light is a particle, there exist these properties. Suppose if it is a light is a wave, ಒಂದು ಲೈಟ್ ಅನ್ನುವಂಥದ್ದು ಪಾರ್ಟಿಕಲ್ ಆದರೆ ನಾನು ಇಲ್ಲಿ ಏನು ಅಬ್ಸರ್ವೇಷನ್ ಅನ್ನು ಬರೆದಿದ್ದೇನೆ, ಇಷ್ಟು ಪ್ರಾಪರ್ಟಿಯನ್ನು ಅಥವಾ ಅಬ್ಸರ್ವೇಷನ್ಸ್ ಅನ್ನು ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತಾರೆ ಲೈಟ್ ಅನ್ನುವಂಥದ್ದು. ಸಪೋಸ್ ಇಫ್ ಇಟ್ ಇಸ್ ಎ ಲೈಟ್, ಇಫ್ ಲೈಟ್ ಇಸ್ ಎ ವೇವ್, ಇಫ್ ಲೈಟ್ ಇಸ್ ಎ ವೇವ್, ಇನ್ ಜನರಲ್ there is no threshold frequency. ಲೈಟ್ ಅನ್ನುವಂಥದ್ದು ವೇವ್ ಆಗಿದ್ರೆ ಏನಾಗ್ತದೆ ಕೇಳಿದ್ರೆ there is no threshold frequency, there is an emission of electron takes place. As well as if light is a wave, ಇಲ್ಲಿ ಒಂದು ಕಂಡೀಷನ್ ಬರ್ತೀನಿ, if light is a particle, above the threshold frequency, kinetic energy of the emitted electron increases with frequency of incident radiation, but it is independent of intensity of radiation. ಇದು ಲೈಟ್ ಅನ್ನುವಂಥದ್ದು ಪಾರ್ಟಿಕಲ್ ಆದರೆ, if light is a wave, just the condition is reversed. There is no existence of threshold frequency. ಈ threshold frequency ಕಾನ್ಸೆಪ್ಟ್ ಇರುವುದಿಲ್ಲ. ಜಸ್ಟ್ ಏನಿರ್ತದೆ ಕೇಳಿದ್ರೆ, kinetic energy of the emitted electron is independent of frequency of incident radiation. If it is a particle, kinetic energy of the emitted electron is increases with the frequency of incident radiation. If the light is a wave, the kinetic energy of the emitted electron is independent of frequency of incident radiation, but it increases intensity of radiation. But the kinetic energy of the emitted electron is increases with the intensity of incident radiations. That is the difference. That is the reason why these cases are considered as drawbacks of photoelectric effect.